Have you done? Have you done? Okay, look at tutorial 6 we already discussed today, right? I mean 2 days ago, right? On last Tuesday. Yesterday. I have tutorial with you all yesterday, right? Oh, okay. Then we continue with our tutorial 7, question 1. So about the asymmetrical fault. So the single line diagram of a three-phase power system is shown in figure Q1. The equipment rating. Yeah, I forgot something. Okay. Oh yeah. Seriously, I forgot to do the recording. Thanks for the reminder. Okay. Uh, tutorial 7 has symmetrical faults. I already go through with you, right? About the unsymmetrical faults, right? You have what is the most important thing is from the circuits. Then you need to 1 minute. Let me open the uh, lecture notes. Yeah, from the questions, then you need to find out the impedance diagram for positive sequence, negative sequence, and zero sequence. Then you have this Z0, Z1, and Z2 value. Okay. After you have this, then you can continue with the symmetrical fault questions, single line to ground, line to line, and double line to ground, right? That's every one of it. There's a diagram represent. For example, this one is single line to ground with this circle diagram. Then you put in the Z0, Z1, Z2 value. Then you find what according to the questions. Okay. So then that's why from actually every questions is question 3 until 7 is actually about question 2 and question 4 means all actually refer to question 1 and 2. Okay. So this one is actually a bit confusing. XD double prime. XD double prime is actually X1. What happened? X1. Okay. So they would give you X1, X2, and X0 value. So it's actually the same thing. What you need to do is you need to find out a positive sequence. You need to find out 3 sets of positive sequence. Then XG1, XG2, XG3, and then negative sequence, and then zero sequence. Okay. So like given G1 and G2, G3 or X1 and X2 is the same, right? Then you can put the positive and negative sequence together. Do you get what I mean? Then transformer value the same. That means you can do another set for X transformer and X transmission line also. A I think something wrong somewhere here. I think something wrong. Should be. So you do like this. But actually, I don't really prefer to combine. I will prefer to separate down into positive, negative together. So here actually is X1 and X2. X1 and X2. So x1 equals to x2. Can you do it now? Have you done? Then based on this circuit diagram, are you okay? So based on this circuit diagram, so then normal, this is a per unit questions that you do like that day during the transformer chapter. Draw the 0, positive and negative sequence reactance diagrams using 1000 MVA and 765 kV based in the zone of line 1, 2. So means line 1, you are using line 1, 2 here, 765 kV. Are you okay? And your new S will be, S new will be 1000 MVA. Okay, have you all of you done? Have you call your name and then give me answer, yeah? Have all of you done? If not, then you please please let me know if you are all of you done. If you're already done, then you type done. If not, then I give you time to do. So I would like to have the answer for positive and negative sequence. G1. G1, then XG2, XG3, XG4. So XG4 you have two, so positive sequence, XG4 negative sequence. Okay, because your XG4 is the one that different. X1 and X2 different. Then we have 0 sequence, XG1, XG2, XG3, XG4. Then we have transmission line, line 1, 2, transmission line 1, 2, line 1, 2, line 1, 3, 1, 3, and line 1, 2 and 1, 3 only, is it? Line 1, 2, 1, 3, and 2, 3. 2, 3 basically same as 1, 2 lah. 1, 2, 1, 2, 2, 3 same. Line 1, 2, 1, 2, 1, 2, 1, 3 H equals to 2, 3. Okay, same here to this one, you need to have excellent. 9, 1, 2, 9, 1, 3 equals to 9, 2, 3. Okay, so I will call your name to give me all this answer, yeah? Have you all done? Nobody respond means nobody done. So I give you about 10 minutes, yeah? You settle this and I call your name, then you need to give me answer, yeah? Okay? Will you know how to do it? So first of all, you need to know where is the new voltage start from here, right? Okay, then you step up and down according to the transformer ratio. So T1 will be 15,765. So the new voltage should be 15 kV here. Then here will be 765 also, I think. 765 also. So here also 765 because without transformer kV. Then 3 step down to 15K. So 15K here. Same thing go to your T2. Okay. Step down to 15K. Okay, Okay, so you need to use there are only two formula, right? Okay, so you need to use the new old new formula. Okay, you get what I mean? X pu new equals to xo vo over v new power 2 s new over so. Okay, so you have, for example, G1, I do it for you. 15k, O1 15k, new one also 15k. So what is the value for G1? G1 is 0.18. So 0.18, 15k over 15k over 2. Then S new is 1000. OS also 1000. 1000 over 1000. So basically 0.18 JPU will be answer. Okay? Okay, please continue to do the rest. Yeah, I will call your name and give me answer. I give you around 10 minutes to do it. Okay? X1212 check back X12 and 1 2 is here. So 1 2 should be equals to actually 1 2 2 3 1 3 is the same, right? Oh, they have different value, huh? Okay. They have different value, but okay. But then 1 3 and 2 3 value the same. So 40 ohms and 100 ohms. So basically if you do 1 3 and 2 3, 1 3 1 3 same as 2 3, 1 3 1 3 I think 1 3 1 3 same as 2 3 because they have the same value. Understand? Because they are having same value 40 ohm and actually you don't want to do it, you want to do it separate also can, just that spend some time long. You have to, the values are the same, equation the same, then you substitute the same thing in, of course you will get the same answer, right? So you do like this 1 3 equals to 2 3, then save your time, and you can actually say here same as this value because they are having the same answer, right? Positive, I'm also a bit blurry. Positive and negative same one, right? Yeah, and 40 ohm and 40 ohm. This one 50 ohm. Okay. For 40 ohms and 100 ohms, right? 0, 1, 2, 0 sequence, positive and negative sequence, all same, right? I can't do that, right? Correct. So means you, yeah, correct. If you get the value from this one, 1, 3, and 2, 3, then means same as the 0 sequence, right? Cannot, or 40 ohms or 100 ohms. I cannot, sorry. Blur already. So why you not understand what I mean? Because they are having the same value. Yeah, so we call 1, 3 and 2, 3 the same. Okay. But you can't say 1, 2 because this is 50 ohms, right? This is 150 ohms. Okay, try to do it now. Okay, done. Xg1, Xg2 for positive negative sequence. Then what? What's your answer? Yes, 0.2 pu. So if you need me to show the steps or you can't get the answer, then let me know. Yeah. Visan, Q3. G3 for positive negative. Yeah, positive negative sequence. Yes, good. 0.2539 JPU. After Visan, who? John. G4 positive sequence. And Kibun G4 negative sequence. Huh? Keyboard not okay. Keyboard why not okay? Which one not okay? Keyboard you say not okay. I feel reset. Means I have problem. I got problem. G4. Okay. We look at John. John, you are John 0.33. 0.3386. You have to give four decimal places. Oh yeah. This one. This is 13.8. Not 13.8 kV. Is it because of this Keyboard? 13.8 kV. Okay, so the old value will be 13.8. The new one for G4, right? Just now. G4. G4 here. G4 is 15K. New one 15K. Okay, so G4. So 0.3. This is X1. Positive sequence. Positive sequence is 0.3. Positive sequence given, right? 0.3. Is it? Yeah. Then O V 13.8, new V 15, power 2, S new over SO. So you should get 0.3386 JPU positive sequence. So for G4 negative sequence, G4 negative sequence will be 0.4. So instead of 0.3, then now you need to put in 0.4. Okay. I think it's Kibun's question, right? Kibun, okay, 0.4. Then 13.8 over 15 power 2 and 1000 divided by 750. Can see Can you all see? Then 0. Oh, answer is a bit messy. 0.41 4514 JPU. Can you all see? Is it too small? Keyboard okay or not? Keyboard, I know why you are not okay. Yeah, so O value, right? Is it because of this? it should be 13.8. So O value is 0.4, right? Then what times with the O voltage 13.8. New voltage G4 here is 15K. Then new S will be 1000. The OS will be 750. Okay. So after Kibun Gok Wing, Ming Hang, can you tell me what's G1 for 0 sequence? Gok Wing G1, Gok Wing G1, Ming Hang G2, Ren Jian G3, Zhong Jian G4 for 0 sequence. For XG3, how do we get the answer? XG3, G3, XG3, O value is 0.15, right? Then 0.15, O voltage value is 13.8, so 13.8 divided by G3 15K, 13.8 divided by 15, then S new 1000, SO 500. So which is something like this. G3 0.15, 13.8 over 15 power 2 and 1000 over 500. You use wrong XP value. That's the thing. Actually, okay one, just that careless mistake is easily get confused, and a lot of data here, right? Sometimes you want to take 0.18, then you certainly take 0.1. Okay, so need to be careful about careless mistake. Also, actually, this question score full marks is okay one. Ming Hang 0.1, 0.1 oh GPU, right? 人间 yeah, G4. Songjian is 0.1129 GPU, correct? And 人间 0.070, I think correct. 0.0708 GPU, I think correct. G3. Who is one who do G3? Godwin. Godwin straight away left the meeting. Godwin. Godwin. Yeah, he really left the meeting. Okay lor, I do lor. So XG3 going. I call your name, then you left the meeting. Yeah. Going, can you do XG3? Eh? So my answer for going. Yes, 0.0846 GPU. Okay, normally we will give 4 decimal places. Yeah. Okay, then we go to the line. X line, Yeah, before x9 we still need to do a transformer. X9, never mind, we continue with line first. So the base of the line should be how much? So base of the line, because all of them actually at the same place, right? So 765. So your V baseline will be what? V squared over S. 765K power 2 over 1000 M. So which is 585.23. Huisan, what's your X12 for positive negative sequence? And Kibun, X1323? X1323, Kun? Have you all done? So I already give you the PU value, right? Base value, right? So what you need to do is you need to use the actual value 50 ohms divided by 585.23 only, you get the answer. Huisan, 1, 2 would be 0. Yeah, very good. 0854 JPU. Then 1323 Kibun. Kibun, yes. 0.06835 JPU. Then we go to the zero sequence. Zero sequence means you have to use 150 and 100 ohms divided by this 585.23. I would like to know the answer from John. Corwin, are you okay? John, you give me 1, 2. Corwin, you give me 1, 3, 2, 3. 0.2563, yes, JPU. Corwin, how about X1323? Hello, Corwin. Are you there? Mm, yeah, not in the test. You may choose not to trust me. Yeah, test until tutorial 6. If you don't want to trust me, then you continue. You can do revision for tutorial 7 as well. Yeah. Final definitely got final long questions. During COVID time, this question I give 40 marks. 40 marks. Okay, I asked from this one. Yeah, seriously, I asked from this one. Then until one of it. Okay. Then why scared you? This is very easy. Okay, then you see, actually very easy, right? Same formula, then you repeat only. Okay, then 1 minute. Give me 1 minute. I want to circle my son a while. You keep playing for the whole day. Okay, where are we? Yeah, so it's actually very easy. So 40 marks, but then face-to-face exam I will separate into 2 questions because I need to follow the number of marks for the one question. So I think 20 marks, 20 marks. So I separate into 2 questions. Can show answer script. Copy what? You want to copy what? Or copy this one? This one is it? Okay. What do you mean by whole answer? Yeah, I will post. This one is a bit messy. I will post the answer for question 1 and 2 to Google Classroom later. Okay. Okay. Where are we? So X 1323 answer for 0 sequence. So not very good. Always answer for calling. 1709 JPU, correct? Then will be transformer. You need to do for every component. So generator done already, line done already, then left transformer. So you have T1, T2, T3, T4. I think transformer, yeah, all of them the same, right? Same for all. X same for all. Means 0, 1, 2, 3, 0, 1, 2, they are having the same answer. So I just write here. After you convert, you should get transformer 0.1 JPU. T2 will be 0.1 as well, JPU. T3 will be 0.24 JPU. T4 will be 0.1467 JPU. Okay, can all of you get the correct answer? After that, then what should you do after that? I will post this answer to Google Classroom later. But this one I'm not really encouraged because they do G1 then positive negative 0 sequence, G2 positive negative 0 sequence. And I think we have careless mistake when you draw the diagram, when you may take the wrong reading. So I will always encourage students to do like what I did, positive negative together. Separate positive negative and 0 sequence. Okay. So of course, if you think you're okay with this, G1, G1, G2, G3, G4, positive, negative 0 sequence also can. You better write JPU. Yeah, supposedly it should be JPU. Then don't care about the double. This one also actually got a little bit problem. So I cannot edit the answer. This answer is from book to book. Just write X1, X2 can already lah. This one no need. Okay, so no need. No need. Okay, then transformer I think okay. Transmission I think okay. Okay, then you need to draw the diagram. Positive sequence draw like this. Only positive sequence is with source. Only positive sequence with source. Okay, then negative sequence without source. 0 sequence. Why 0 sequence look like this? It is because still remember I just told you before. Delta, right? There's delta open. This side also open because the Y, didn't link to ground. Here also Y didn't link to ground. So here all here open. Okay, so it will have something like this. Okay, any question? So it will be G1, XG1, then XT1. And X line 1, 3, x12, line 1, 2, x line 2, 3, then line transformer 2, G2, transformer 4, the T4, G4, uh, T3, G3. Okay, what is V squared? V squared divided by S is here. V squared divided by S, right? V squared divided, correct? Am I, am I writing the wrong thing? Eh, eh. Oh, V squared divided by S. V squared, correct? V squared divided by S, right? To find the base, sorry, not V base, Z base got 整歪. If you want to find the this is impedance, right? Impedance in ohms, actual value. Then you need to find the base value, right? For the base value for impedance. So in order to find impedance is actually V squared over S, right? We have this one R equals to V squared over P, right? Something like this. So we have V squared over S complex power. Okay, so that you can find the base value, the Z base for the line. Okay, so you get a new V value 765 kV over 2 divided by 1000 MVA. Okay, then you get 585.23. So once you get this base value, then you use this actual ohms divided by base value. Okay, I hope you recall it is something okay discussed before, right? Okay, understand? Set base. Okay. So any other question? So once you have this positive, negative, and zero sequence, then the next question they will tell you where is the fault. So where is the fault? Question 2. Faults at bus n in or of the interest. So select n equals 1. Determine the Thevenin equivalent circuits of each sequence as viewed from the fault bus. So pre-fault voltage is 1 pu. Pre-fault load currents and delta Y transformer are indicated. Okay. N equals to 1. So n equals to 1 means okay. Supposingly, yeah, it should be here, right? So supposing your fault is here. But this is not a good way to describe the fault location. Normally in your test or exam, I will say label as F. I will have a cross label as F. Okay, that means that it's a fault bus. Okay, so I think the fault bus is bus N. Yeah, bus 1. Yes. Bus 1 here. Bus 1 here. Bus 1 here. Okay, so when your fault is here, that means what? You need to find out what you need to do next. After you draw this diagram, right? Okay, so what you need to do is you need to find Thevenin equivalent. Okay, your eye need to look inside here. So you basically, this one is a T, so you need to use a T to pi transformations. Okay, then this one that short everything off, short the voltage source. Then this one basically is parallel. Then here T to pi transformation. Yeah, do you get what I mean? Okay, something like this. So that's all you need to come out your Z0, Z1, and Z2 value. So how you get a Z0? Z0 means from this zero sequence diagram, your eye look inside here. Okay, so means what? This one T to pi transformation. So you do a T to pi transformation. Then this will be in parallel. Series is this one, right? Right, I think so. Then, yeah, parallel, you have these two parallel. You have this value. Okay, then see 1 line, 2 line, 3 line series together. 1, 2, 3 line series, 1, 2, 3 lines parallel together. So you have this answer. So negative and positive sequence, yeah, they are the same. Not the same, a little bit a different value, but same way of doing. Okay, so t to pi, then parallel here, then series them together. Parallel you get here, this one parallel, you get here, then series them together. So it's parallel. Anyone have any problem regarding this? So basically you have your x2 value and x1 value. x2 and x1 is quite similar. You just have slight difference in this value only. This value only, yeah. This value. G4 value. Okay. So they use the same method and substitute different value. Okay. Are you okay? If you are okay, then I plan to stop here. Okay. But I think you don't want to stop here, right? So we continue a little bit more. Yeah. Why does the zero sequence look like that again? Okay. Actually, it's a bit actually, if you want to ask, right, if it can be explained in a very complicated and yeah, very detailed way. But then actually, I not really care about this y delta thing. So basically, if you look at your past year questions, in order to ease your work, I will put all y transformation. If I put y with ground, then all the negative sequence and zero sequence will be the same. Okay, so this is actually not the every year actually students ask this, but this is actually not the main concern because it's actually higher level of power systems that actually delta y, this kind of thing can be a big subject to study. Okay, so a big topic to study. So I will make all y ground, y with ground. Okay, so to explain again, yeah, from what I know and what you can know that this, because it's a delta. So still remember in delta we can't be in which chapter? Symmetrical component chapter. I think chapter 4B, right? I think it's in 4B. Sequence network chapter. Delta. If it is a delta load, your zero sequence need to open because you don't have any neutral line in delta network. So your zero sequence need to open circuit. Okay. So according to that theory, Nicholas, okay, you have delta here, that means all open. So this side no more, this side no more. And this is because of this side no more, it is because of one of the y is not linked to ground. So if one of the line is not linked to ground, you have like this, right? Then suddenly link, and then this one not linked, that means all not to ground. Understand? So all here gone. But basically it's not a big concern in your final exam, okay? Your final exam according to past year all will be y ground. So if all y ground, that means your, do you get what I mean? I'm trying to give you hints. If it is y ground, that means that it is actually negative and zero sequence are the same. Can you get what I mean? It means your zero sequence will look like negative sequence. Can you get what I mean? Okay? Nicholas, okay? T1 and T2. T1 and T2 are not open circuit. Based on my understanding, is because it is delta here open already open here, and then this y ground is actually means it will stop at here and then straight ground to. Actually, I know my explanation is a bit yeah, may not able. Actually, I so cannot not able to accept this. the explanation, but then as I say, this is actually a big topic if you want to know the Y delta thing. There is actually a table, and yeah. And this question actually I asked Dr. Yao before, and he also can't really explain to me. So that's why I say no need to really need to care about the Y delta stuff. As I said, in your exam it will be all Y ground. Nicholas, are you okay? Nicholas, you need to force to be okay. Okay, if it is all Y ground, what does it mean? If it's all Y ground, grounded Y, that means your no, if it is Y ground, that means you don't need to do anything. It will be normal, like negative sequence. Only Y not grounded or delta, then it's different story. You need to open for delta and Y not grounded. So if Y ground, then means it is exactly like negative sequence. Means nothing open or neglected. Follow the diagram. Means you just follow the diagram. If it is Y, or here Y grounded, okay, Y grounded here. That means you follow diagram. Understand? Follow diagram. Open Y ground. You didn't open the Y ground. Why you open the Y ground? Here actually you don't care about this question. Don't care. It's actually a long story to discuss for delta or Y ground. As I say, this is actually a topic in higher level. So for your level, because we choose this question in tutorial, so this is some problem. This is a small problem here, but actually, you actually supposing if you want to, I mean, have to accept for this zero sequence diagram. Yeah. So if this is delta, then you open here. So that's why you don't have the thing G1, right? And your G2. Okay. You don't have G1 and G2 because it is a delta, so it's straight open already. Okay. So here you transformer, then you straight to ground. So transformer straight to ground. So you only have T1 and I think so. You only have T1 and T2, right? Yeah. So for this part, it is because of this part missing. It is because of here, as I said, Y ground and not grounded and grounded here. So one of it is not grounded, then all gone. Are you okay? But then, as I said, this is a detailed explanation is actually in higher level that I'm not in that level yet. Okay, so and I also asked Dr. Yao about this before. Then he also actually not really able to explain. Okay, but that's the thing. So my understanding will be this is what he told me lah. Understanding is like this all but why need to ground together? If one of it not grounded, then all gone. Okay, then in order to avoid problem in your final exam, so all the transformer I give Y ground. Okay, so if it is Y ground, then you follow diagram. Okay, others, are you okay? Song Jian, Minghang, Ryan, Ying Xuan, Ziyuan. Yeah, I think I didn't call your name, Ziyuan. Did I? I didn't call your name to do question. Okay, Y grounded, then follow diagram. Okay. So basically your final exam just follow diagram. Yeah, this one I give hints already. Okay, next question 2 done. So question 3, determine the subtransient fault current in PU and in K during the bolted 3-phase fault at the port bus. Okay, in question 2. So Question 2 actually, so all of this question 3, 4, 5, 6, 7 actually follow question 1, 2. So once you get the answer for 0, 1, 2, solution. So once you get the answer for this one, Z0, Z1, and Z2, then you can continue with the rest of questions. So this one, for question 3, you will only choose a positive sequence because only the positive sequence will have. Okay, question 3 is actually symmetrical fault. Okay, for third three-phase bus faults means all the three phases are short together. So it is actually symmetrical fault. Okay, which is not in the unsymmetrical fault, mean single line to ground, double line to ground, or line to line fault. Okay, so calculate the fault current in PU and in KA. So why we only choose a positive sequence? Because only positive sequence will have source, voltage source, 1 PU. Okay, then you use Ohm's law, I equals to V over Z, then you get the answer. I0 and I2 will be equal to 0. Negative sequence and zero sequence currents will be 0. So then you convert to IA, IB, IC using the symmetrical component chapter. Okay, you get the P value. Then you multiply with the base value. So SI equals to S over 3V, 0.7547 K. Then you get the actual. So the double prime here, no need to care about it. It shows a subtransient. No need to care about it. You just write IA, IB, IC can already. The bar also no need to care about it. You just write I1, I0, I1, I0, I2 can already. Okay. Okay, any question? So this is for the three-phase symmetrical fault. So after that, any question? Am I too fast? After that will be single line to ground fault, single line to ground fault with ZF, then line to line fault, double line to ground fault. Okay? I would like you to do it yourself, and we will discuss next week. Okay, something like this. Okay, something like this. Okay, okay. I will discuss next week. Are you okay? If you don't have any questions, then please use the time now to complete the tutorial questions for 4, 5, 6, and 7. And I will meet you all next week. I think next week, week 10, right? The formula for converting T to pi is not in. It's in the notes or not? I don't think it's in the note. In the circuit analysis, not got lah. Circuit analysis, two-port network chapter have. This is not a problem, right? Google they also have the formula already, right? T to pi conversion. Okay, because this formula you all learned before, so it's considered the fundamental formula, so I didn't put in the formula. By the way, no formula list, even in your final. Go to refresh all the formula. Okay, but normally it won't be T to pi is just in this case only. The circuit need T pi transformation. You may be ready for it, but not necessary. You will need to use it. Okay, you need to look at the circuit shape of the circuits or circuit structure. So if you can't do parallel series, then only you use T to pi transformation. I mean, it look like not series, also not a parallel. Then you consider T pi T transformation. Okay. Other than that, don't use because if you use it, then you will make the simple thing more complicated. Okay, if you don't have any question, then our class will stop here. I give you time to complete question 4 to 7, and then we will discuss next week. Next week is week 10, right? Okay, week 10, yeah? So our test will be our test in week 11, yeah? Monday. Okay. So next week we are going to complete this and the last 2 chapters. Okay. If you don't have any questions, then we will end here. Thank you. Bye.